At Central High School, the math club has 15 members and the chess club has 12 members. If a total of 13 students belong to only one of the two clubs, how many students belong to both clubs? Let's go ahead and draw our little Venn diagram here. And there's two ways to do it. One is to do it the way I recommend or often do with Venn diagrams, and that's remember that the sum, well, I'll get to that in a second. That's one way, and the other way to do it is algebraically. I'll show you both. So first, this way. So let's go ahead and just label everything first before I start talking about the theory here. So this is the chess club circle, and so let's actually make this the math club circle, and we'll make this the chess club circle. Now, the total number of members in the math circle, including the overlap, is 15. The total number of members in the chess circle, including the overlap, is 12. But we also know that these two guys individually must add up to 13, right? So we know that this green plus this green adds up to 13, and the remaining is this. So this is what you have to remember when you do it the Venn diagram way. When you add up the 15 and the 12, what you're doing is double counting the middle. You're double counting the overlap, right? Because I counted once with the 15, and then I add the 12 in, and I count it again. So when I go ahead and add 15 plus 12, I get 27. Now, again, that's double counting the middle. So if I subtract out, in this situation, if I subtract out what I have here, right, the green, which I've deleted, if I subtract out this and this, which is 13, so I subtract 13, I'm going to be left with 14. Now, what does that represent? Remember, this 27 represents single math, single chess, and the overlap twice. So if I subtract out the single math and the single chess, I'm left with the overlap twice. So this is 2 times the overlap. In other words, 2 times the number of students belonging to both. So all I'd have to do is just divide by 2, and I get 7, and that's choice C. That's one way to do it. It's all about knowing how the Venn diagrams work and how you add together the pieces to get what you're looking for. So that's one way to do it, but there's another way to do it which has to do with Venn diagrams. Now, the SAT's answers, the College Board's answers on the site are a bit different here to how I do it, but ultimately it's the same thing. So you can check theirs out if you want to see their method. So this is our math again. And this is our chess. And let's call the total number of members, or excuse me, the number of members in just math X, the number of members in just chess Y, and the overlap we'll just call little b for both. Now, what equations can I make here? Well, I know that the X plus Y, so the number of people just doing math and just doing chess, is 13. And I know that the number of people doing math, whether by itself or with chess, is 15. So I know that X plus the overlap, so X plus B is 15. And I also know that Y plus B is 12, right? Because the number of people doing chess, whether by themselves or with math, is 12. So I can add those two up. And now I can just do a couple substitutions because I can rearrange this to get X equals 15 minus b, and y equals 12 minus b, and I'll substitute those in here. So I make that substitution, I'm going to get 15 minus b plus 12 minus b equals 13. So I'm going to get 27 minus 2b equals 13, minus 2b. And do a little rearranging, I'll get 2b equals 14, which, by the way, twice the overlap is 14, like we got before. So b is 7. Which is what we had before. So either way, you're really doing the same thing in both circumstances. It's just how you conceptualize it and how you actually do the work. Do you do it with the Venn diagrams or the algebra? Either way, whatever gets to the answer, that's what you're going to want to do.